But they are, yep, and Megan's here and Megan's recording. But the cartridges are they are pricey. Um, but you can also do this with like coffee filter paper or filter paper. You can also do this with like just like really concentrated Kool-Aid. So hopefully you did do the pre-step of making your Kool-Aid. I've got both green and purple. So if one person is just, you know, they're really jazzed and they want to see one over the other, but you should have created your Kool-Aid. Essentially, you want less water and more Kool-Aid. And I can send you teacher instructions if the instructions that Megan gave you is not simplified enough and you just kind of need like extra teacher tricks and essentially just teacher tricks. But you should have your Kool-Aid created. That's the first thing. So y'all give me a thumbs up if or whenever you get your Kool-Aid ready. Got one Kool-Aid done. Awesome. Got two Kool-Aids done. So one of the things that I mentioned earlier is that we were going to be doing some math. And the first page of your instructions is a worksheet that you can give your students. And it's about determining concentration of solution. And even if like you are teaching middle schoolers, learning how to do math like this, it's just multiplication and division.
In class, we just say C1V1. Like that's how we say it. And
am I crazy? Did anybody else hear that, or is that just
my kids know we just
it's because Megan has something else recording?
But C1.
Yes, that's Trisha. I can hear her.
How many?
So you do have this worksheet in your binder, and it talks through how students can make different types of solutions. But what I wanted to go over with you is how to use the equation. So the equation is C1V1 is equal to C2V2. And that's dealing with your concentration of the solution. Like, is it a 10% solution? Is it a 70% solution? Is it a 90% solution? And then the volume of the amount of the solution that you need. So I'm going to do math that's related to our experiment today. So we are using a 70% isopropyl solution. So that's our original, or C1. There's my 70% solution. And I don't know how much I need of that in order to make my 5% solution and my 25% solution. So over here on my little paper towel, I've got my little cups that I'm going to use later, and I've got them mapped out with my 70%, my 5%, and my 25%. So if my second solution is going to be 5%, that's going to be my concentration for my C2. And depending upon the number of students in the instructions, it talks about making a huge batch quantity. Depending upon the level of your students, when I did this with high schoolers, I would make them do the math and then create the solutions themselves. If your kids are not to that level, you can at least show them the math on how to go about creating solutions. But again, it is basic math skills. It's a fun little multiplication. So I'm gonna make my solution today. So just like using 25 milliliters. So that's gonna be my volume. So I want 25 milliliters of my 5% alcohol solution. So I would do 5 times 25, which I did pre-math. I'm cheating. So that's going to be 125. And I don't know what my V1 needs to be. Like, how much of that 70% isopropyl alcohol do I need in order to make this diluted solution? So I've got my 70% that I already know about, and I've got my volume 1. So if I divide by 70, that's going to tell you how much of that 70% isopropyl solution I need in order to make a 5% solution. And my previous math shows that this is roughly 1.7 milliliters. So that means in your tiny graduated cylinder, you would measure out 1.7, which if you have a micropipette, you could, or if you have 1,000 micropipette, you could do it. If you've got kids with non-steady hands, 1.7 is a little difficult. You could easily round up. So then that would tell your kids that they need 2 milliliters of the 70% isopropyl. And since I want 25 milliliters of a solution, that means that the other 23 milliliters are going to be the distilled water. Does that make sense with everybody in the group? Going too fast, I can send you screenshots of all of this as well. So just going back, your C1 is your initial concentration. The volume is what we're trying to solve for. That's our variable. We know the concentration of the solution that we want to make, which is a 5%, and we'll do this again with the 25% solution. And because you only need about 10 mils of your alcohol in order to perform this experiment, I didn't want to be wasteful, so I just decided to go with 25, and also it works really well with the little cups that Megan gave us. So again, you multiply, you get 125. I'm going to divide by 70 because that's my initial concentration. Get 1.7. It's actually like 1.78. So you can easily round up to 2 mils, which is easy to do, which then means the rest of the solution is going to be your distilled water. So if you like, you can proceed to make your 5% solution. And all I did is I put mine on paper towels. You can do this with conical tubes. Megan has a ton of them, and then you can pop them in a test tube or on a beaker. If you need more help with this, I can send you a really great YouTube video. There's a girl that does step by step walking through how to make the solutions, and it's literally called Kool-Aid chromatography, and it's for STEM. She's kind of cutesy, and she does like all of the prep work and walks you through it. But that is how you make your solution. 2 milliliters of your 70% isopropyl. And again, if you have a 1,000, 1,000, you can easily do it with that. Also, kids just really love playing with graduated cylinders. My sixth graders, they know how to measure the meniscus. They think it's fun, measuring stuff on scales. You can spend one day just playing around with solutions. Sorry, I'm looking for my meniscus at the current. So once you've got your 2 milliliters of your isopropyl, you get your 23 mils of water, and that's going to go in the same container. Everybody doing okay? Good. All righty. There's your 5%. And then you do the exact same equation, but now with 25. on that. So we're still using 70%. So we're still back on our same equation. So my C1 is still 70%. I will not know what my volume is. That's what we've got to determine. But now my concentration, I want it to be a 25% solution. And I'm still wanting just 25 milliliters of that 25% solution. So I'm not wasteful with it. So you multiply 25 times 25, which is it is 625. Then I'm going to divide by 70, determine how much of that 70% that I need. And when you do the math, it comes out to be 8.9. So you can round up to 9 milliliters of your 70% isopropyl, which then 9 minus 25 is going to be 16 milliliters of your distilled water. 9 and 16 is 25. So you can proceed to make your 25% solution. I hope everybody is doing it.
Cynthia, just a question.
Yes, ma'am.
Um, I'm looking at what we have there. You changed some of the figures or the numbers?
Yes, ma'am.
Okay, all right, great, thank you. What you're actually working on right now, you're looking at number 3?
No, I'm doing the solutions for our experiment. I'm going to go back and work some of the ones on the piece of paper. I figure we could go ahead and get our solutions created for this experiment.
Okay.
So the first solution that you use is just the pure isopropyl at 70%.
Mhm.
And then after we have gone with the 70%, it's called charging the cartridge. Then you use your Kool-Aid. Then it's your 5% solution you use, and then it's your 25% solution that you use at the end. So the math that I'm doing here is actually what you need to do for your experiment. Does that make sense?
Okay, all right, thank you. Because I was actually working the one that was actually in the book, but all right, thank you.
Well, I'm going to go back to the worksheet. I figured we just throw this in so that way you could go ahead and have your solutions ready, and then we can work on the worksheet.
All right, great. So I should make a dilution from this dilution that you have there.
So the first solution that I have is my basic 70% isopropyl. It is literally just some that I poured into the beaker or into a small little cup because you're going to need it for your experiment.
Mhm.
And then you use the 70% isopropyl to create your 5%. That was the first equation we did.
The first one, yes. Mhm.
Yes. So for your 5%, you need roughly 1.7 milliliters of isopropyl alcohol. You can round to 2 because it's not going to be enough that differentiates the molecules.
Okay. Mhm.
And again, if you want to be really accurate with your kids, you go 1.7 because some of these have small enough tick marks, or if you have micropipettes to do the tick marks on those, that's totally appropriate. But for little hands, you can just round up to 2.
Okay, great.
So you would use 2 mils of the 70% isopropyl. And then because I'm simplifying it because of what we're doing tonight, if you were making a large stock solution for all of your students, because the instructions require for you to use 10 milliliters, you would multiply that 10 mils by however many students you have in the classroom. So these numbers would change because I'm just using this at my desk and I don't want to be wasteful. Roughly 25 milliliters is going to be enough for what we have to do. So the 2 and the 25 mils. So there's 25 milliliters of a 5% isopropyl alcohol solution in this tub.
I do have that, yes. And the
And
next
then,
one,
yeah, the next one that I did was for the 25% solution. So you're still using 70% isopropyl alcohol.
great.
So since I want to make a 25% isopropyl alcohol solution and I still want to do 25 milliliters of my total solution, because again, I don't want to be wasteful,
Okay,
you're still going to divide by 70, which then it comes out to be 8.9 mils of 70% isopropyl alcohol that you're diluting. So you can again round up for little hands to 9 milliliters. And then 16 plus 9 gives me 25 milliliters of total solution. So the 16 milliliters is going to be of your distilled water.
thank you.
No worries. So, and if you don't have 70% isopropyl alcohol, you can do the exact same thing with 90%. So then you would modify your equation. Instead of 70% as your initial concentration, you would have 90%. So the dilutions would be slightly different. And you can actually, make your kids work that math out. Like, oh, I've got 85% isopropyl, but I need a 70% solution, a 25% solution, and a 5% solution. So the equation is still the same with your initial concentration and your volume. With your second concentration and your volume, you're just dealing with a different percent solution. Everybody okay? Would anybody like me to work through some of the problems that are on the worksheet? Yes? Okay. So I'm just going to use this one. So in question number 1, it says a student needs to make 150 milliliters of a 5% isopropyl alcohol solution. So the equation is still the same. The C1V1 is equal to C2V2. But the problem is telling us that the student wants 150 milliliters. So that's my volume 2. And they want a 5% solution. So that's my initial concentration. And the student has on hand 91%. So that's their C1. That's their initial concentration. Because again, isopropyl can come in a bunch of different percentiles. So the same with what we're doing right now. The student doesn't know how much of that 91% isopropyl alcohol they need to dilute it to make a 5% solution with 150. So same thing. Again, I'm not a mathematician, so it's going to be 5 times 150. That's going to give me 750. I'm going to divide by 91. So I'm going to need 8.24 milliliters of the 91% isopropyl. So since this student is making 150 milliliters, they would take 150 and subtract the 8.24, and that means the remaining 141.76 is the amount of milliliters of distilled H2O the student is going to need in order to make that concentration. Does everybody understand that? So the first part is the A part. up here. And what I did over here on this side is actually the B part, which what are the steps? And that's that they're going to need 8.24. And again, this is going to just be the math equation. So the kids can actually do the amount of sig figs that you want them to do. But the 8.24 milliliters is going to be of the 91% isopropyl alcohol. And the 141.76 is going to be the amount of distilled H2O, because this equals the fact that they are making 150 milliliters of a 5% isopropyl alcohol solution. Does anybody want me to work more? One more? Okay, that's fine. I don't mind at all. So on number 2, it says how much of a 70% isopropyl alcohol solution will be needed to make 200 milliliters of a 25%. So we know that we are using a 70% isopropyl. Our volume 1 is our variable. We know that we are going to need a 25% solution, and we're going to create a total volume of 200 milliliters. So again, like if you're doing a stock solution for your class, like let's say that you have 100 kids throughout the day and you want 100 kids to do that. Well, 100 kids are going to need 10 milliliters each. You know that they're probably going to spill a good chunk of that 10. So you of course need to give them more than that. So that's where you would know the volume that you need and what percent solution you need and how much of the initial alcohol that you have on hand, like what percent solution it is. So, and I apologize, I can't do math in my head. So it's going to be 25 times 200. So that's 5,000. And then I'm going to divide by 70. So I get my variable by itself. Your math teachers will be happy with you that you're doing math. So 5,000 divided by 70. So the answer is 71.42. That's 71.42 milliliters of the 70% isopropyl alcohol that this student's going to need to make a 25% concentration solution with 200 total milliliters. So if the 71.42 is the alcohol, you subtract 200, and that means 128.57 milliliters is the distilled water to finish out your solution. Are y'all ready to watch magic happen? And this definitely does get like the ooh, ah, wow factor with your kids. If you're into teaching molecular compounds, on my lab, I show the kids the molecules. And you can show middle schoolers molecules, it doesn't matter. And one big thing about this is like the movement of the molecules is based on the size of the molecules. So let's just say that you teach high school and you want to do chemistry lessons, the blue food dye and the red food dye, or the blue food dye and the yellow food dye. Those molecular structures are online, and also the chemical formulas, like how many molecules. And again, there's more math there. They can count up the number of carbons and nitrogens and this and that and other in the food molecules. But on the back of your Kool-Aids, it actually tells you that it's red 40 and blue 1 with the grape Kool-Aid. And then in your green Kool-Aid, it's yellow number 5 and blue number 1. So again, you could do like a web quest with your kids and have them search up the molecules and see how big they are or how small they are. So does anybody have a preference on which color you would like for me to do tonight? Purple or green? Do we have a vote?
Purple.
Or green? It's a vote. All right, purple's, oh, nope. Who wants to tell me their favorite color? Purple or green?
Green.
Okay, we're going green then. So you've got your Kool-Aid solution, and in your instructions, it walks you through step by step what you're going to do. But the first thing that we do is we charge the cartridge. So one of the big things about these syringes is that liquid never comes up the cartridge. It only goes down the cartridge, okay? If they suck up a solution up through the cartridge, it can damage them. So that's the one big thing. They can never pull solutions up the cartridge. So take your cartridge off of your syringe if it is currently on there and set it to the side. One thing that I just always let my kids do is always put your syringe top down in one of the wells. So in your procedures, it tells you to draw up 10 milliliters of your 70% isopropyl. So this one is my 70%, and I put them in order of use. That also helps with your kids. And I just used a piece of paper towel and I wrote them on there. Or you can label your containers. So this first one's my 70, this is my 5%, and this one's my 25%. So using your syringe, you're going to pull up 10 milliliters of your 70% isopropyl alcohol. Once your syringe is full, you're now going to put your cap back on your syringe. And just so you know, you should, if you're looking at your syringe, you should be able to read the chromatography or the C18 syringe. Everybody good? Okay. So all you're going to do is what you're doing here is you're charging the cartridge.
I think we
Sorry.
might have a question.
Oh, sorry.
I'm sorry. I'm a little behind. How many solutions did we create? Just two?
You created two, a 5% and a 25%.
Okay. And so
You're using the 70% in the beginning, so you don't have to make a solution there. It's just what's coming out of your alcohol bottle.
Okay, very good. I just want to make sure I'm on track.
Oh no, you're good. Stop me anytime if I'm going too fast. I tell my kids that all the time. Talk way too fast. So is everybody good on their syringe with their 10 mils of 70% isopropyl? Yeah, IPAs. It's also a good lesson that we tell kids not to drink medical grade stuff. Lesson about, because they'll be like, but that's alcohol. Can you drink it? The answer is no. This is used for sterilizing and for doing science experiments. All right, are we ready? So your syringe should be on the bottom, and all you're going to do is you're just going to slowly dispense the alcohol into one of your wells. And if you go over a well, just go into the next one right beside it. Did they give y'all the six well ones or the ones like mine?
We have 6x4s.
Oh, you do have 6x4s? Okay. If you ever get like the 6 well plate, this works really well with the 6 well plate. The 6th graders would, or the middle schoolers would ask what would happen. You could get very sick. You could get alcohol poisoning. And then you can have a whole fun lesson about what happens to your liver and the smoothie are inside of your liver. And then you can get cirrhosis and jaundice and turn yellow. There's a whole lot of conversations that you can have about that. So you're just going to slowly push your 70% through your cartridge.
We're gonna place it in 4 or the 6 of them.
Excuse me?
We're gonna place it in 4 or 6.
Honestly, it doesn't matter which wells you put them in.
Okay.
I start from the bottom. If you want to start from the top, you can.
Okay.
So in this column chromatography, you're going to pull out 3 different things, but I'm not going to tell you what those 3 different things are. That would ruin the fun. All right, so that took me about 4 wells just to push all of that through. Now, in the procedures in your notebook, it says to push through 10 mils of distilled water. You don't have to do that. It works without it. So has everybody pushed through their 70%? Get a thumbs up from my people who have their. We're good. We're good. Yes. Beverly? Yes. Okay. So take your syringe off. And the next thing that you're going to do is you are going to pull up through your syringe 10 mils of your Kool-Aid. So y'all wanted me to do green, so I'm doing green. If you're doing purple, then you get your grape Kool-Aid. Once you have your Kool-Aid in your syringe, you're going to put your cartridge, your column back onto the bottom. Again, liquid never comes up the column, it only goes down the column. Once you've done that, you are going to slowly push your Kool-Aid through your cartridge. And here's where some of the kids may be like, oh my God, what's happening? What kind of voodoo magic is going on here? So slowly dispense your Kool-Aid through your column. Again, if one of your wells fills up, you can just push into the next one. Y'all have some magic happen. Starting to see cool stuff in your column. So once you push your Kool-Aid through, you're going to take your syringe off again. And now you're going to go into your 5% solution. So you're going to pull up 10 mils of your 5% solution. Once you have pulled that up, you're going to put your syringe back on top and proceed again. And again, this is a really great time just to talk about observations, what we see, maybe what we smell later on. So you're just going to push through again.
Oh,
It's crazy.
Oh, Rowan, are you having a fun science moment?
Yeah, it's cool.
Trust me, your kids will think it's cool too.
did anybody else have purple?
I did purple too.
Do you have red?
I do.
Yeah.
Okay.
So red is a smaller molecule than blue. The blue molecule is bigger. So
Gotcha.
this is where when you do like your pre-work with your kids,
Mhm.
when they look at the size of the molecules and count the numbers of carbons and nitrogens and what other like fun elements that are in the chemical formula, red is the smaller molecule. So the red molecule, or in my instance, the yellow molecule is the smaller molecule. So it's going to fall out of the column first.
Gotcha.
And then because the blue molecule is the bigger molecule, it will fall out second. It's also fun with like DNA. So this is a great time when you can reference this later. Like if you do chromatography before you talk about DNA, In gel electrophoresis, the smaller molecules move faster through the gels. The larger molecules get stuck. It's the same kind of concept about small and big molecules. So once you've pushed through all of your 5% solution, you're going to take your cartridge off again. And now you're going to pull up 10 mils of your 25% solution. Once you've got your 25% solution, you put your cartridge back on. So all of the red should have come out of yours, did it? You feel like you still have a little bit of red in yours. If your kids have a little bit of red come out or a little bit of the yellow come out on a secondary flush, it's not a big deal. Just tell them to like switch over to the next one, or they can actually do the 5% over again, because it will still trap the blue molecule. Another thing about these columns is about polarity of solutions. So when we're looking at a 5% solution versus a 25% solution versus a 70% solution, we're also looking at polarity of molecules, like what likes water versus what doesn't. So if you have your 25%, you can put your cartridge back on and then push it through, and you should have some more fun magic happen, because
Yay.
my blue is coming out big time, right?
Mm-hmm.
So those of you who did purple, you're getting your blue right now too.
Yay.
So if you do this with Kool-Aid on filter paper, you can create like the same kind of column concept in a plastic cup with a lid, and they tape the little paper to the top of the lid, and they can watch the molecules move up the filter paper with the exact same type of alcohol solutions as well. So mine still has a little bit of blue in it. I don't know if y'all's does or not, but if it does, all you do is you take your cartridge off, get more of your 25% solution, and push it through again. I still have a little bit of blue in mine, so I'm going back to my 25. Again, as long as you're not pulling solution up through your cartridge, these things are reusable year after year after year. Mine still has a hint of blue. So once your kids have gotten out like the different dyes, again, you can talk about small and big molecules. They've created solutions. And then also talking about the application of why scientists do this. So there's a lot of real life application on this, especially like maybe if the high school teaches forensics. They do drug testing with this. So let's just say that a student athlete has something in their urine. Oh, they can test it doing column chromatography, seeing what falls out first or second. Um, in the Food and Drug Administration, like with beverages, they use this as well. Nutrition analysis of what vitamins and minerals are in food substances. Let's just say that Jane Doe or John Doe passed away. They can do something like this with similar, if there's chemicals in their blood or their urine, stubbing contents, all sorts of really great application with this, and just like finding out what substances are inside other substances. Pesticides with agriculture. And when you're done, you can, if you're still like mine still has a slight little faint of it, I might actually like if the kids were finished, I would push more alcohol through it later. And then when you're really done with it, if you take your syringe and fill it full of air and put your cartridge on it, you can push out. It'll make like a little foamy sound, but it will dry out your syringe so that you can use it over and over and over again. And there you go. There's your column chromatography. I'll get good colors. When you do the one with 6, there's a step where you can that it's actually clear, and you can have your kids waft it and they can actually smell the grape Kool-Aid. There's actually a smell component in it. Y'all have any questions?
Do you have the lab report or not lab report?
I
Lab
do.
acceptance
I can
report?
send it to you, Rowan,
Awesome. Thank you.
anytime. Do you want it to, Miss Williams?
Yes, please, if you wouldn't mind.
Yeah. All of y'all's names are in the email that Megan sends out. So I can easily forward you my teacher makeshift one that I use.
Okay. Thank you.
Oh, you're welcome. I have 20 something years of doing a whole bunch of crazy stuff, so I like to help other people. Do y'all have any other questions about the math?
It's been a long time since I've done concentration and volume math.
Yeah.
It's been a long
But
time.
again, are you in middle school or high school?
Middle school, middle.
Hey, the basic multiplication and division is really important, and those
Agreed.
babies struggle.
Yes, they do. Yeah.
And also, it can teach them how to use Desmos. I don't know if y'all have Desmos
Yeah.
on your learning platforms,
Yeah, we do.
but getting those kids comfortable with using Desmos
Mhm.
early on, because that is something that they are going to use for the rest of their high school careers.
Mhm.
On EOCs, it's the only calculator that they're allowed to use. So
Mhm.
getting them like really familiar with that early on, math teachers will thank you.
Mhm. Awesome.
And I can't remember. Megan, can you hear me? I hope so. Would you like any of them to send you pictures?
Yes, please.
Megan
Anytime you
wants to
take a
show
picture,
y'all.
send it our way or
If you
put
didn't
it on
take a
social
picture,
media.
it didn't happen, right? Isn't that the rule of social media?
Yeah.
That's true.
And I will tell you, like at my middle school, the kids are not allowed to have phones,
Right.
but encouraging your kids to take their time and kind of dangling the carrot above their heads that if you do your lab right, I'll let you take a picture. They really put their effort into doing a really good job.
Mhm.
I did a rainbow density lab in a tube where they have to do it like really well. And if they mess it up, like it turns into poop water. But I told the kids, I'm like, if you do really well and you make a beautiful rainbow, I'll let you take a picture of it. I only had 2 kids out of 120 something kids that made poop water. Those kids were, "Yeah, I sent it to my mama." And I'm like, "That's awesome. Did you tell your mama what you did?" And they're like, "Yeah." So again, it's a fun way for the kids to get to use their phones, but they're also taking really cool pictures of science. And then I also make them write a little quick text message to mom about what they just did to kind of like solidify learning.
Awesome.
Do y'all have any other questions?
This was fun.
Remember, kids like to do labs, and for those of us who are middle school, this is the first time that they've really been able to do science
Mhm.
and any kind of things. And I'm going to plug middle school in a hard way. Like, we don't have a test that is connected to our curriculum in middle school. Let the kids play with lab supplies. They get so excited, even if it's just a ruler. I mean, they want to do stuff. They want to be hands-on. And you know, like I let mine play with food coloring with the graduated cylinders. I even taught them that if they go over how to use a pipette and take the water out or only add a little bit back in. And like those kind of like textile lessons are so important because they will take that with them. Like my kids know graduated cylinders are for measuring volume and that scales and triple beam balances are for measuring mass. Like even at the middle school level, I think they're totally capable of doing hard things. We just have to raise the expectation and
Mhm,
they'll meet us.
mhm.
Okay, I think I'm off. I just love science and I think it's fun. And I love to see their little faces light up when they have the aha moments or, like just doing cool stuff or like I put a rock in their hand and they had never seen that type of rock before and they're like, "Ooh, what's this?" And it's like, "Oh, this is pyrite. Isn't that cool?" Like science is fun. And I think if we can engage them earlier, we will make little scientists out. If y'all don't have any other further,
Are
yes,
these
ma'am.
these wells are reusable, correct?
Yes, ma'am.
Okay,
Now, if you were doing like chemistry and like you did reactions and stuff, that would not be appropriate.
right,
But for what we're doing with Kool-Aid, you can pop them in the dishwasher, get them cleaned out, use them again.
okay.
Yes.
Cool.
And again, and if you don't have something like this, grocery store, little itty bitty clear plastic cups.
Mhm.
Totally do that.
Awesome. This is fun. I like this.
And if you guys, can I, Cynthia, for a sec?
Go ahead, Megan.
If you guys choose this lab for your implementation, I'll send you a class set of well plates, a class set of the syringes and the chromatography columns, like the little columns. The information for the column is in your binder. There's a care sheet and it has the email address for the guy that we get them from. So there's a small company in Norcross called Sorbtech. And I buy a box of 50 at a time. So if you know you're going to use them like in multiple classes, you could email him to buy a whole box. It's like 200 something dollars. But it works out to like $3 a column. Whereas if you buy them from Flynn, they're like $11 a piece. So, but if you want to do it as your lab, just shoot me an email and like I'll send you all the stuff to do it. And then you can keep that and just keep reusing it year after year.
And are you also the email contact for getting in touch with the stockpile that they were talking about earlier? Or would that be Cynthia? Okay.
The PPE thing, that's me.
Yeah.
Oh, yeah.
Yeah, so just for that, email whatever time during those windows that you want to come and I'll send you a calendar invite, which puts you on that guy's calendar, so he knows you're coming.
Cool. Thank you.
We need some aprons, don't we?
Hmm.
Oh, sorry, I don't have those.
Rowan and I are in the same school, so.
Oh, that's right, yeah, but we don't have paper towels, but there's plenty of like gowns and
Aprons,
they have
yeah.
some
Yeah.
gloves, masks, tons of masks.
I think
So
you sent me a box of aprons last few years ago.
yeah,
Yeah.
yeah, they have the plastic gowns that you can
Yeah.
use as chemistry aprons.
Mhm.
So yeah, any of that stuff, get them in the PPE.
Okay. Sounds like a plan.
She's got cleaning wipes too. They're awesome.
Thank you for the tip.
Beverly, are you good?
Well, I stopped talking. But if you guys are done, you're welcome to be done for today. I think I made all the announcements I had to make, and I'll send anything else an email.
Thank you.
Good, thank y'all.
Thank y'all.
Thank you guys.
Question, please. Question?
I'll hang out if anybody has questions.
In regards to the calculation that we did, should we submit that to you?
I don't need your calculations, but please send me pictures of your well plate and any of the
Okay.
labs that you complete.
All right, great, thank you.
Thank
All
you.
right, bye-bye.
Bye, Dacia.
How do I get out of here?